Hello everybody, welcome to the R Help video about homework 8 for STA 371G. There are two main topics I'll be going over today. The first is converting from log odds to probability, and the second is how to use a logistic regression model. So for the first topic, converting log odds to probability, you can do math or you can use a vector. By do math, I mean you can solve for your log odds and then go through all these steps I'm about to show you without making vectors. I like doing it this way because it makes it very simple. But if you'd like, you don't have to create vectors and you can just follow whatever I have after the equal sign and keep track of what you're calculating. So let's say you start with log odds. In the homework, it will be given with an equation sometimes where you have to plug in different information. Once you run the equation, it will give you a number. So let's say we start with our log odds as 1.61577. Make sure you run each line so that the subsequent lines can work. So to go from log odds to odds, you do x and then whatever your log odds are. X is telling it to raise e to the power of whatever's in parentheses after. You'll have to use exp because log odds are ln, so the inverse operation is therefore e to whatever power. After you have your odds, you can get your probability by doing odds over 1 plus odds. Don't forget to use parentheses here so that your order of operations is correct. So odds over 1 plus odds is the probability. Your probability will appear in the global environment, or you can run your probability line and it will give it to you. So the probability here is 0.834 or about 83.4%. Our next topic is the logistic regression model. So the general format of this model will be model name equals GLM y tilde x, comma data equals data, comma family equals binomial. So you'll notice this is very similar to the linear model. There are a few differences. I'll point them out to make it easy to remember. First, instead of LM, you'll put GLM. The second is that ensure you write family equals binomial. You don't write family equals anything for linear models, but it's absolutely necessary for logistic regression models. Let's go through an example. In your homework, you'll be using this set, walk the dogs. So I'll use it for the example. Model equals GLM, y tilde x. So let's say we're predicting walk, yes or no, from the steps, which is the x, comma data equals walk the dogs, family equals binomial. So let's run our model. It worked, and we can see our model has been created. So you can follow similar commands that you do in linear regression. For example, typing the model name again will give you the coefficients. Doing summary model will give you the coefficients, the standard errors, different values, and the degrees of freedom and such. If you want to make a prediction, you use the predict function, predict, model name, comma, list, whatever your x is. So here it's steps. Make sure you don't write your y here, put your x equals however many steps you want it to be, comma, type equals response. Make sure your response is in parentheses. What this will do is predict probability. So this is an important distinction to make. It doesn't predict the log odds or odds. It goes straight to predicting the probability. So make sure you remember this. We can run the command, and our probability if steps equals 4 would be 0.234. Another important thing to note is you can still use the conf function. You run it the same way, conf model, and then your confidence level. You can write your confidence level, or you can just remember it defaults to 0.95 if you're using a 95% confidence level. And here are the intervals. If you have a question that wants you to calculate the percentage of the time the model correctly predicts walking the dog, you'll want to use p is greater or equal to 0.5 as the threshold for predicting a yes. Essentially, what this is telling you is that if the probability is above yes, since this is a binary model, you'll say yes if it's above 50% and no if it's below, because you can't predict something intermediary. So if you want to predict how many times the model thinks you walk the dog, predicted walk equals predict model, comma, type equals response, and then you put in your criteria. So this means greater or equal to 0.5. So just to reiterate, this code is saying if you predict the probability, just like you did up here, and it's above 0.5, R is going to mark that down as a predicted time you walk the dog. So if you run that, we have a vector for our predicted walks. An actual walk is when walking the dog's walk column is actually equal to 1. Make sure you write 2 equal signs instead of 1, and we can run it. And finally, if we want to see the times when we predicted correct, sum when the predicted walk equals the actual walk divided by n row, which is saying the number of rows in the walk the dog set. We do 100 times this to get it as a percentage of the time instead of a proportion of the time. So we can run it, and this is saying we correctly predicted, or rather our model correctly predicted, 67.26% of the time. Now, something important to remember is our model isn't as valuable if simply predicting the most common outcome predicts the same amount or more correctly as our model. So in this instance, we can run some actual walk, which again is the times the dog was walked. And we can see the dog was walked 68 times. However, there were 223 total times in the set, which you can see by scrolling down on the data, 223 observations, or you can scroll down and see all 223. This means we walked the dog 30.5% of the time about. This means if we predicted every time that we didn't walk the dog, since this is the most common outcome, not walking the dog, we could see how good our model is. So 1 minus the sum actual walk. This part is important because since we're saying not walking the dog is the most probable outcome, we do 1 minus walking the dog. And this would be whatever the most common outcome is. So just to reiterate once more, the reason I'm doing 1 minus sum actually walking the dog is because the most common outcome was not walking the dog. So this divided by, again, the number of rows. So if we predicted the most common outcome and then multiplied by 100 to get the percentage instead of proportion, we would get 69.51% of the time. So what this is telling us is if we just predict the most common outcome for everything, instead of actually trying to use a model, we predict right almost 70% of the time, whereas when we use our model, we predict right 67.26% of the time. So I hope this video was helpful. Thanks for watching.